to the middle. Okay, let's stop a little bit. So everyone is still with me here. Any problem?
Just a second. I'll move the mic there.
Yes. Yeah. So actually, this one is gonna go a little bit into the technical side. So what we are gonna use today is called linear regression, and one of the main so one of the main main thing we should check with linear regression is that the data follow follow a normal distribution. Like it's usually work much better with with normal distributions than any other distribution. And then we also have some kind of technique to correct this thing, correct this skew distribution into a normal distribution. For example, I can say that for this problem, you can probably use some kind of log transformation to make it become normal distribution. It's just easier. Of course, you don't have to deal with it if you cannot. It's up to you to make the model as good as possible. Yeah, here I provided some to-do. You can take it as some hint of what to do with the data, what to code here. And of course, you can ignore it and do it your way, no problem. So, after looking at the data, in our routine, we have to deal with data processing. What we mean by data processing is just looking at the data again, see the features and identify what is important. For example, here, I have already identified and visualized some important feature for use. Again, we have 80 features here. So it's encourageable for you guys to just visualize a lot of things and see the connection, the relation between the feature and our target variable. You can use my helper function here or write one by yourself. Here, for example, here in this graph, we can see that the ground living area has a linear relation with our sale price. By that I mean the higher the living area in square feet, the higher our sale price, which makes complete sense. Because the bigger the house, the higher the price. That's normal. The same for the frontage and yes, basement floor, basement area. Yeah. Okay. For the lot frontage, we can see that there's some point that doesn't lie in the same cluster with the other data. That's what we call an outlier. An outlier is something bad for our model, so it introduces false information, and you will usually have to exclude the outlier from our data set before processing. Here I excluded it and visualize the graph again, so you can see the linear relation clearer. Also, there are some what we call categorical features that might be important. Categorical features is thing that doesn't take on continuous value and only take on a predefined set of value. For example, here the class of the house, the type of the house can take on a few values here, like from 20 to 190. And the condition of the house is from 1 to 10, etc. etc. In the visualization, you can see that some features have a clear relation to the target variable. For example, here in the overall condition, overall quality of the house, you can see that the higher the quality, the higher the price.
Is anybody having a problem understanding?
Yeah. I'm just going on and on, but is everyone having any trouble? Just remember, if I want to follow me, so if you have any trouble, raise your hand.
No, it's separate from your competition. Eventually, it's going to be a competition, so you better ask your teammates eventually. But now we try to run over everything very quickly, so feel free to follow, or you can actually start thinking about next steps.
Okay. Oh, by the way, if you have enough experience and you can vote, and feel free to get a head start. No one will stop you with that. Let's continue. I also provide some insight from my own here. If you want to take a look at and see how we look at the data, what conclusion we can draw from looking at our graph. This is somewhat important, and it helps you to understand your data better. The more insight, the more exact, the more you can exactly do the feature engineering at the next step. This one is for a correlation matrix that show a lot of information, like the relation between pairs of feature. You want to take a look at the brighter color cell here. That usually mean two features sharing a lot of information, and usually we don't need both features in our model. We can try to use just one. Okay. So that is for the identifying the important feature. Again, I already identified some important feature for you, so feel free to skip this one and jump straight to feature engineering and modeling if you want. Next up, cleaning the data. Here is usually this is a very time-consuming part of data science, like cleaning the data, make it pretty, make it something we can work with. But since we don't have enough time today, I take the liberty to do it for you guys, and you guys can focus more on modeling and feature engineering. Just remember, hit enter to clean the data. For experienced people, you please try out different cleaning strategy if you have time. Okay, first step, feature engineering. Is everyone still with me here? Any problems? Okay, feature engineering. By feature engineering, like Hong has already explained to you, we want to make important features, remove some unimportant one, and maybe transform our data into something that's easier to work with. Here I only do a very simple feature engineering for you guys, and just this is one of the parts I want to focus your attention on, and try to work out different strategy for feature engineering. The better your feature, the better your model. And lastly, modeling. That's maybe what excite most beginner. So modeling is just put like input the data into a machine learning model and have the model learn from the data and try to make a prediction. So what exactly we are doing here. I provide some helper function, and you can just put the data into the model, define the model, feed the data into the model, and after a while it will throw out a score, and you can see if your model is doing good or bad. So for a recommendation for the unexperienced here, so you can try to improve the model by playing around with different kind of model with different set of parameters. That's usually the easiest thing to do to improve the model. Here I provide a very simple baseline model for linear regression. There's a lot of different models you can try on, which we will show in the slide later. And finally, if you are stuck, then we have some staff here who will help you advance. And also you can ask your teammate to know what you should work on. I also provide a link. This is a link to Swivl. This problem is originally from Swivl competition, and a lot of people have already do something about that. And you can see what people are doing here. If you really want to try to not to copy paste and understand it, but
can you quickly explain what is Swivl? So somebody doesn't know about that.
Okay, so for people who understand with Swivl is just a platform for doing data science competition. So you can you have some problem, you work on the problems, and then you submit the solution, and maybe if you good enough, you can get a prize from it. Okay, that's all. So I want to make sure that everyone has successfully completed the notebook. So are you guys? Okay.
If there's no question, then we can move on to the next.
I expect more impression here, but
everyone is actually in the competition mode, right? So make sure that you grab some water before you jump into the competition. Yeah. We have a lot of water behind you.
We talk a lot, and yeah. Basically, I think you guys are just eager for the real competition, but too bad Phong still have something to talk. So Phong, let's make it quick, and everyone is tired already.
Yeah. Decide the tables maybe, and we can just split into groups.
Before that, if you wanna go to take some drink or go to the toilet, maybe you can just take a 5-minute break.
Yeah, it's a bit overwhelming, isn't it? I think it's a little bit hard for those who don't have any programming experience at all. But that's the point, right? You start the first step into the world of technical, into a technical world. So you know that we data scientists actually usually some environment called notebook, and we run the code by writing it and execute it by shift enter, right? So we actually did all the hard work already by writing all the codes for you already. Some of the concept I already explained. I may explain further when we group into team. Okay? So don't worry, when we group into team, feel free to ask all the experts in the team. Okay, and I want to provide a quick knowledge for today. Important model. So everyone knows that we should build a model in order to estimate or predict the price of the house. But what kind of model it is? is a very important concept in data science. Okay? So now I really want you to pay attention to this. So in data science, there's a lot of different problems. So one of the problems that you must have mentioned is classification, which means you classify the data into category, right? Category doesn't have any linear or it's not a continuous number. But for a continuous number like housing price, it has to use regression model, okay? Remember this term, regressions is a model to predict a number, a continuous number, which is, for example, housing price. So what is a regression model? Okay, I think all of us has learned in high school maybe the line formula, right? Yeah, it's basically y equal to beta 0 plus beta 1 times x. It's a line model, it's a line formula for line function. So a linear regression is actually a line function, that easy. So our prediction or target is y. Y, our features are the independent features, variable, which is x. So this is only one variable. How can we generalize it into multiple variables? Because we have many columns. So if we have multiple columns and multiple features, the line formula becomes more general. Basically, you have multiple beta and multiple x in a product function like this. It's a sum of product, right? So beta 0 times x0 plus beta 1 times x1. So the task of a machine learning is to tune and to find for you what is the best beta over there. And when you plug in the x, it will calculate for you the y, which is the selling price. Okay? So let's think about this problems, a very simple problem. Let's think of the y-axis as the selling price of the house. Okay? And the x-axis is the size of the house. Let's think of it as a very simple problem. So the bigger the size of the house, absolutely the housing price should increase, right? It should be more expensive. So our job is to find the best line which fit the data. And how? And how do we do that? So basically you see there's going to be an arrow when we draw a line. So this arrow is calculated as a distance to the line. Our job is to find a model have the least error. So the arrow has to be the smallest of all the models we have. We want the arrow to be the smallest. Why we want to be the smallest is common sense, right? Our model has to be good so that the arrow is small. Okay? And the method to do that, we call it least square method. Why we square the arrow? Why we square the arrow? It's simple because some arrow has positive value and some arrow has negative value. If you sum all of them without squaring them, you would end up like arrow canceling out each other, right? So we want to have a method simple enough. So we square all the arrow to make it all positive, so that we can minimize this arrow. And there's some formula to do that. You feel free to go through the slides we already given to you to understand more about the mathematical concept behind this. But everything is taken care in the machine learning library we already written for you in the notebook. In order to build this model, actually you only need to write 3 lines of code, only 3. Very, very fast. And when we group up into team, our expert will tell you exactly where is the part you are building the model. Okay? So don't worry too much about that. I will skip this. And finally, before we group into team, I want to give a quick recommendation for everyone. How to deal with this data set and what should you do to achieve a higher results than the current baseline model. Okay? for the people who new to the field, okay? So you can try some of other model beside the regressions model. For example, like polynomial regressions, ridge regression, lasso regression, neural network, or a simple decision tree. We will tell you what to do when we work up in the team. Or substitute some models parameter. We also will tell you how to do that. And for those who have experience in the field, I see that some people who read name tag, you are experienced. So you can try a little bit of like a more challenging approach, like choose a different features you think it is important to the model. Because at the end of the day, your model is built on top of the feature. If you choose a good feature, you will have a better results. Okay? And focus, yeah, that's why you focus more on feature engineering, and you can try some of advanced method, like some of the keyword here, boosting, stacking, example. If you in the field, you should know about this. So don't worry, we will guide you through. Okay. So, okay. So before we go to the competitions, just at the end of the session today, please take 5 minutes to evaluate the sessions. Okay. So now let's group into teams. So I already observed, and I want to do something like this. So the first two tables, can you turn around? The first table turn around and join with the first one to become one group. Group one, you two do the same. Then you turn around and join with the second table to become one team. The third table, can you also turn around to become the same group with the table behind it? And the last two rows, you guys on the last two rows, you join the left side and the right side, join with each other to become one team. Okay? So I will make the rule like this. Everyone, we discuss a little bit about the problem. Our assistants will join each of the team and provide you some hint. So we have two evaluation metrics for our models. One is root mean square error. Another one is called R square score. So which team who has the lowest root mean square and highest R square score will win today. And that team, each person will have 5,000 yen vouchers from Tokyo Tech East. Okay? Okay? So you can use that for any other service from Tokyo Tech East. And after that, the winning team will give a brief presentation how they solve the problem with better results. Okay? So let's do it, everyone. Let's group into team. And we have 45 minutes to do it.
Okay. Your Japanese is fluent? I speak very little, so yeah, okay. Yeah, okay. Could you maybe be the moderator in that sense? Because my Japanese is very little.
Can I join your team?
It's okay. I can follow the Japanese a little bit. Yeah. If I don't understand it, I will ask you English. Yeah? Oh, okay. You're fluent both in English and Japanese, right? Could you be maybe the moderator of this? Yeah, moderator or translator. Yeah. Okay. How's everybody's experience in Python? Nice, yeah.
Might change.
So now we want to divide, like everybody will try to implement a different model. Like do you make or will we divide like in feature engineering or motor?
自分は自分でピックアップしないといけないです。何でもいいとかじゃなくて、一番意味がある。それは本当にまさにご自分のお仕事になっているので、みんなの方を選んでください。面積とかリビングルームのサイズとかそういったようなものももし大事だと思ったら
Is it fair?
Yeah.